Hello everyone. Today I'm going to discuss about Diffie-Hellman key exchange algorithm. Okay, so whether we will call it as Diffie-Hellman key exchange algorithm or Diffie-Hellman algorithm. Okay, so suppose I want to share one information to someone else. Those people they may sit in the other countries or other remote location. So there may be so by using some public channel, we need to send our information to other side. Okay, so whenever we are using some public channel, the security is the biggest factor. Okay, even though that channel is it's a secured one. Okay, so in order to resolve these kind of problems, so we need some efficient algorithm like Diffie-Hellman key exchange algorithm. Okay, so this Diffie-Hellman key exchange algorithm is a one type of symmetric key algorithm. So symmetric key algorithm is all about same key we will use on the both side, like sender side as well as the receiver side. Okay, suppose one person he wants to send some confidential information to other side. Okay, through some secure channel now. So we need to encrypt the message with the help of some symmetric keys and finally send it to other side. Okay, this is the normal process. But sometimes, so this Diffie-Hellman key exchange algorithm, no need to send the keys. Okay, so with the help of some public key of other side like user side, user B and receiver side. So we need to calculate the key in the sender side. So similarly, in the user B side, like receiver side, so with the help of sender side public key, they can calculate the private key of user B. Okay. So likewise, they will calculate the same key on both sides. Okay. So that is the objective of this Diffie-Hellman key exchange algorithm. Okay. So without any exchanging of any keys in the insecure channel, they are calculating with the help of their opposite side public keys. Okay, so this kind of algorithms we will call it as Diffie-Hellman key exchange algorithm. Okay, so there are some steps are involved to find out the keys, symmetric keys. Symmetric key means same keys are generated on sender side as well as the receiver side. Okay. So now let's see. So this is symmetric key encryption. Usually encryptions it is all about the plain text is converted into ciphertext with the help of some keys. So here we only focus on key generation. We only focus on key generation. Similar key generation on both sides, like sender side as well as receiver side. Okay, so that our data it may be sent in a secure channel in a secure way. Okay, so now let's see the process of generating symmetric keys. Okay, now let's see. So let's see the procedure of Diffie-Hellman key exchange algorithm. Okay, so the first step is we need to select one prime number. We need to select one prime number. So the first one, assume that the prime number is equal to 11. Okay, so the prime number is equal to 11. Okay, so after assuming the prime number, we need to find out the primitive root. Okay, so which means with the help of that prime number, we need to find out the primitive root. Okay, so primitive root of p. Okay, so now here primitive root. Okay, so primitive root of p. Okay, so primitive root of p. So which means, so here assume that alpha is the primitive root. So alpha is the primitive root. So this alpha it must be less than the p. Okay, so alpha it must be less than p. Okay, let us assume that. So first we assume the prime numbers. When we assume the prime numbers, we need to find out the primitive root. That primitive root value it must be less than p. Okay. Now let's see how to find out the primitive root. Okay. So the primitive root it can be calculated based on the prime numbers. Okay. Let us assume that here the prime number is 11. So from 1 to 10 we need to calculate. Okay, for example, 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that is the first one. So here 1, 2, 3, 4, 5. So up to 10. Okay, so up to 10. So we need to calculate. Okay, so the first row is the power values. So first row is the power of the first column is the power of first row. Okay, so the first one is power. So the first one is power of. Okay, so the first one is power, and this one two power values. Okay, so two power values. Now what we'll do? Now we will write 1 power 1. So 1 power 1 is the 1. Okay. So 1 power 2 is the 2. 1 power 3, it is 3. Oh, sorry, 1 power 1, so 2 power 1, 1 power 1 is 1. And 1 power 2 is 1. 1 power 3 is 1. 1 power 4 is 1. So similarly, all the values we will get 1, 1, 1, 1. Okay. So we don't have any problem. Okay. Here we are not satisfying the condition. So the condition is whenever we are calculating the power values, okay, so we will get all the numbers like 1 to 10. Okay, so here we will write it is mod 11. Okay, so mod 11. Okay, so now we will calculate 2 power 1. Okay, so 2 power 1. So 2 power 1, what is the 2 power 1 value? 2 power 1, 2. Okay, so 2 power 2, 2 power 1, 1. 2 power 2 is 4. 2 power 3 is 8. Okay, so 2 power 4, 16. So 16 is beyond the 11. So 5. Okay, so 5. And 2 power 5, 32. So 32 now, 3 into 11, 33. And 2 into 11, so 33. So 2 power 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32. So 32 by 11. So 2 bar 22. So 32 is 22, 0, and 3 to 1. So 10. So 10. And 2 power 6, 64. So 64 by 11. Okay. So 5 into 11 is 55. So 55 plus 9, 64. Okay, so 9, 64, and 2 power 7, 128. So 128. So what is the 128 value? 1 into 1, 11. So 18. So 1, 7. Okay, 7. And 2 power 8, 256. So 256 by 11. Okay, so 256 by 11. So 2 into 11, 22. So remaining 3, 36. So 3 into 11, 33. So remaining 3. Okay. So remaining 3. And what about the next one? 2 power 9, 512. So 512 is divided by 11. So 4 into 4, 4 into 11, 44. So 44 remaining 7. So 72. So 16 into 11, 66. So 6. Okay. And 2 power 11 is 1024. So 1024 is divided by 11. So what is 1024? 9 into 11, 99. So remaining 3. So 33. So 3 into 11, 3. So remaining 1. Okay. So we will get all the values from 1 to 10 in the second row. Okay, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we will take these two as the primitive root of p. Okay, so primitive root of p. Okay, so here alpha is equal to 2. Okay, so this is the way we can calculate the primitive root of prime number. Okay, for example, these. So again, we will do calculation for remaining 10 numbers. Okay, but we may satisfy the same condition for remaining numbers also. But this is enough for calculating the key generations. Okay, so the thing is we need to calculate. So the value it must be 1 minus p. The value it must be placed in 1 minus p up to 1 minus p value, so that this 10 is there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the column also 1, 2, 3, 4, 5, 6, 9, 10. Also, okay. So this is the way we can calculate the primitive numbers of uh, prime number p. Okay. So that primitive number, it must be less than prime number. So here 2 less than 11. So 2 less than 11, the condition is true. Okay. So we will do the further process. Okay. Now what we will do? Now we need to find out the private key and public keys. Okay, so we need to find out the private key of center side and private key, public key of center side, as well as, okay. So here alpha is equal to 2. Okay, so the condition is true. So what is the condition? The alpha, it must be less than p. Okay, so alpha, it must be less than p. So condition is true. So 2 less than p. Okay. So now what we will do? Now what we will do? We need to find out the user private key, center side private key and center side public key, and the sender receiver side private key and receiver side public key. Now we will find out the sender side, okay, and sender side private. Okay, so center side private key and public. Okay, so center side private key. So what is the center side private key? Let us assume that sender, say, A. So user X private key. Okay, so user X private key, it must be less than the private number. Okay, let us assume that user A private key is 2. Okay, so sorry, 3 or 4, whatever, we will take anything. Okay, so let us assume that that private key is 4. Okay, the sender A private key is 4. Okay, after that, what will happen? Now we need to calculate the public key of center side. Okay, so how to calculate the public key of center side? So A, okay, so A. So sender side private key. So sender side user X private key and user X public key. Okay, so user X public key. So here P user, assume that B is the public key and Y is the sorry, X is the user A. Okay, so user X public key, it can be calculated based on the user X private key. Okay, so here alpha A power A base X mod 11. Okay, so this is the way we can calculate, we can find out the sender side public key. So what is the alpha value here? Alpha value is 2 and 2 power 4 mod 11. So how do you do that? 2 power 4, 16. So 16 mod 11. Okay. So now we will get 5. So B public key. Okay. So sender B public key is 5. Okay. So now we calculated user X private key as well as user X public key. So this is the user X private key. Okay. So this is the user X private key. So AX user X private key is 4 and user X public key is 5. Okay. So this is the way we can calculate the sender side private key and public key. Okay. So now we will calculate the receiver side private key and public key. Okay. So receiver side private key and public key. So how do you calculate the receiver side private key and public key? Now we will calculate. Okay. receiver side private key and public key. Okay, so what is the receiver side private key and public key? Okay, so receiver side. Okay, so receiver side, receiver side. Okay, so receiver side user Y. Okay, so user Y private key assume that 3. Okay, so we need to calculate the public key of user B. Okay, so these are way. So how do you calculate that? So the help of that primitive rule. Okay, so we need to find out the public key of receiver side. Okay, so what is the alpha value here? It is 2. So 2 power 3 and mod 11. So what is the 2 power 3? 8. So 8 now, so 3 is the 8 now 3, sorry 8. So 3 is the receiver side public key. Okay, so receiver side public key. So here receiver side. Okay, so receiver side private key is 3. Okay, and the receiver side. Okay, so receiver side private key is 3. Okay, and receiver side public key is 3 also. Okay, because 2 power 3 8, 8 mod 11 3. Okay, so now we calculated sender side private key and sender side public key. So sender side private key 4, sender side public key is 5, and receiver side private key is 3, and receiver side public key is 3. Okay, so now we need to calculate. Um, Okay, otherwise we will do one thing. So instead of 3, suppose if we are giving 4, okay, suppose the sender side value is 4. So what is the value of this one? So 2 power 4. If sender side private key is 4, 2 power 4. What will happen? 16. So 16 plus 11, 5. Okay, so like that we will get the sender side and receiver side private key and public key. Okay. So private key is 3, so 8, 2 power 8, 2 power 3, 8 mod 11. So 8 mod 11 is 3 is the public key of sender receiver side. Okay. So now we know sender side, private key and public key, receiver side, private key and public key. Okay. So through that, we need to generate the keys. Okay. So through that, we need to generate the key values. Okay. So how do we generate the key values? So one formula is there. So through that, we need to calculate the key generation. Okay, so key generation phase. So key generation. Okay, so key generation is the next phase. Okay, so now what we will do? So private key means we only knows. Public key means everyone knows. Now in the key Diffie-Hellman key exchange algorithm, so we may utilize, suppose if you are calculating the suppose it is assumed that the sender he wants to calculate the symmetric keys. You want to generate some keys with the help of receiver side public keys. Okay. In the receiver side, similarly in the receiver side, they will calculate the keys with the help of sender side public keys. Okay. So this is the way we can generate the public keys. Okay. Now let us assume that, for example, we need to generate keys in the sender side. Okay. For example, with the help of the receiver side public keys. So what is the receiver side public keys? by. So with the help of receiver side public keys, okay. So with the help of the receiver side public keys, we need to with the help of receiver side public key and sender side private key like AX, we need to calculate the key generations. Okay, so by default, what will happen? So here, we know the by values. What is the b values? It is 3 and 3 power 4 mod 11. Okay, so what is the 3 power 4 values? So 3 4 times. So how do you calculate 3 power 4 times? 3 into, so 3 into 3 into 3. So 3 into 3 is 9. 9 into 3, 27. So 27 into 3 to 81. Okay. So 81. So 81 mod 11. Okay. So 7 into 11, 77. So 77, 4. Okay. So key is 4. Okay. So the center side key is 4. The center side key is 4. Okay. The center side key is 4. Now we need to calculate the receiver side keys. We need to calculate the receiver side keys. So how do we calculate the receiver side keys? Similarly, we will calculate the receiver side. Okay. So for example, okay. So k is equal to, so with the help of the sender side public key. Okay, so with the help of the center side public key. So what is the center side public key? B basics. Okay, so we need to the help of the center side public key and receiver side private key. So what is the receiver side private key? Is a power a base y and mod 11. Okay, so here with the help of these things we will calculate the private key. So what is the bx value? Is 5. So base power ay is 3 and mod 11. Okay, so what is the y? So we will get 4. Okay, so k is equal to 4. So center side and the receiver side both are calculating the keys. Okay, so finally they got the similar keys. Okay, so this is we will call it as symmetric key encryption. So both center side as well as the receiver side, they are generating the same keys. Okay, so it is having these algorithms having minimum risk. So without sharing the keys, in a public channel, so the users utilize other public key credentials and finally they will generate the keys. Okay, so this is the way on both sides they are generating the keys. Okay, so finally they will achieve the symmetric key encryption concept. Okay, so this is the way the Diffie-Hellman algorithms are works in network security concept. Okay, thank you for watching.